I am WY Sitaraman. I am an assistant professor here in the Mechanical Engineering Department at University of Wyoming. Before I came to Wyoming, I used to work at NASA Langley Research Center. And at the time, my research was on helicopters. I designed helicopter rotor blades, did fluid mechanics analysis using high-performance computing on helicopters. So the decision to come here was basically use the knowledge on helicopters and wind turbines because they're similar kind of systems. They both have rotating blades. We have one high-performance computing system for our group, which is here, which has 512 cores. And then we also use the Yellowstone Supercomputing Center that just came up. This is a standard wind turbine, there's a model of that. So we try to model that. So what we have to do is to model the flow patterns around it. Wind turbines are lifting bodies, it's producing lift, and lift is basically contributing to torque. So you can see that there is this tubular structure at the tip of the wind turbine. It's basically very similar to what happens on an aircraft wingtip. It's air that rolls up around that, and then it travels backward essentially. It took about 200,000 core hours to get the simulations. Now that's one single turbine. What we can also do is several turbines, like in a wind farm. You can see all of the 48 turbines seeing the wind. Here red represents high wind, blue represents low wind. So the question is, how can we arrange this system such that the entire wind plant can produce large amount of power? We have run up to about 16,000 CPU cores for large-scale simulations. And our ultimate goal is to be able to simulate an entire wind farm. For example, Wyoming is getting a 1,000-turbine wind farm in the next 2 years. Our contribution would be to simulate that wind farm and perhaps suggest design alternatives such that power can be maximized.